If gas costs $4 a gallon and one is going to drive a compact car on a 200-mile trip, what is the difference in fuel costs required for this trip between the most fuel efficient and the least fuel efficient compact car? So if we look at the compact cars, we see the most fuel efficient one is 50 miles a gallon. The least fuel efficient one is 10 miles a gallon. So if you go 200 miles at 50 miles a gallon, all you're going to need is 4 gallons. Whereas if you go at 10 miles a gallon, what you're going to need is 20 gallons. Well, how much do each one of these cost? Well, 4 gallons at $4 a gallon costs $16. 20 gallons at $4 a gallon costs $80. The difference between 80 and 16 is 64, which is answer choice A. The range from the least fuel efficient station wagon to the most fuel efficient is what? So remember that range means basically the max minus the min. The highest number minus the lowest number is the range. So if we look at station wagons, looks like we're going from here, which is about, we'll say about 14, to here, which is about, we'll say that's about 42. And 42 minus 14 is 28. So that would be the range. And this is answer choice B. In how many different categories is it possible to select a vehicle with a fuel efficiency of 28 miles per gallon? So if we look at 28 miles per gallon, which is about here, and we just go up the graph, we cross compact cars, mid-sized cars, station wagons, and SUVs. And so there are 4 categories that we cross. So it is possible in 4 categories to have a vehicle that has a fuel efficiency of 28 miles per gallon.
This is a hard question. If we were to take the average number of marketers at 5 of the companies, excluding Fermion, then this average would be approximately how many employees larger than a Fermion were included in the average. So we're comparing 2 different averages, one with Fermion included and one with Fermion excluded. So this is the one that we're thinking of excluding. And so the other companies, let's see, we have, appears to be about 57, 35. This one appears to be about 66. This one appears to be about 45. And this one appears to be about 52. Okay, so we know 45 plus 35, that's 80. We know 52 plus 57, well, 50 plus 50 is 100, 2 plus 7 is 9, so that's 109. And then we're adding 66 to that. Well, this is 189 plus 66. Well, 180 plus 60 is 240. 9 plus 6, 15. So this adds up to 255. So let's get a little more room here. We have 255, and we are dividing this by 5. Okay, so what is 255 divided by 5? Well, we know that 250 divided by 5 is 50, and so 5 more, that equals 51. So that's the average. Now what happens if we include Fermion? So this is the average without Fermion. If we include Fermion, we have that same sum, 255 plus Fermion, which appears to be about 18. So 255 plus 18 is 273. And we want to know how much does 6 go into this? 273 divided by 6. Well, let's think about this. 240 is 6 times 40. 246 is 6 times 41. let's see, we can add a few here. We can add from 240, we can go up 33. So let's go up to 270. So we add 30 more. So that's 6 times 45. And we're very close to 45. And so the average, this would be about 45 and a half. So let's approximate that as 45. That's the average with fermion. So the average without fermion, 51. The average with fermion, 45. We want to know the difference of those two. Well, 51 minus 45 is about 6. So let's look at the answer choices. And 6 is the answer. Answer choice A. At Jericho, approximately what percentage of the non-management employees are marketers? So we're looking at the Jericho bar. And here we can do some real approximation. This green bar is what percent of the whole bar? Well, certainly that green bar is huge. It is way more than half. And so it's definitely not going to be 51% or anything smaller. So we're down to a choice between 66 and 72. Well, think about it this way. 66 is 2/3. If it were 2/3, it would mean that we could take this piece and then 2 more of those pieces would be the size of the green bar. But clearly the green bar is more than 2 times this purple bar. And so this green bar has to be more than 2/3, more than 66%. And so that the only possibility left is 72%. Answer choice E. So at Pindar, there are approximately how many more programmers than marketers? So we look at the Pindar bar, starts at 0, looks like it goes up to exactly between these two lines, so that would be 35. So there are 35 in marketing. And then it looks like it goes up to 92, so 35 minus 92. Well, or 92 minus 35. Well, 92 minus 30, of course, is 62, and then we'll subtract the 5, and that's 57. And so 57 is the number of programmers, 35 is the number of marketers. Notice both of those are answer choices, but notice that the question is not asking for how many programmers or how many marketers, how many more programmers than marketers. Okay, so we have to subtract now 57 minus 35, and that gives us 22. Answer choice B.
All right, let's begin by calculating the number of Japanese graduates in 2003. According to our chart, there were 4,800 graduates in 2003, and 10% of them were Japanese. So the total number of Japanese in 2003 will be 10% of 4,800, which equals 480. Now let's determine the number of Japanese graduates in 2004. The chart tells us that there were 6,000 graduates in 2004, and 8% of them were Japanese. So the total number of Japanese in 2004 will be 8% of 6,000, which equals 480. So we have the same number of Japanese graduates in 2003 and 2004, so the percent decrease will be equal to 0, which means our answer is A. To answer this question, we'll take the total number of French students who graduated in 2004 and subtract the total number of French students who graduated in 2003. Let's begin with 2004. The pie chart tells us that in 2004, 21% of the 6,000 graduates were French, so we can add that information here. In 2003, we're told that 21% of the 4,800 graduates were French, so we can add that here. At this point, we can take 21% of 6,000 and rewrite it as 0.21 times 6,000. And on the right-hand side, we can rewrite 21% of 4,800 as 0.21 times 4,800. At this point, we can save ourselves a little bit of time if we recognize that we have 0.21 in both of our products. As such, we can factor out 0.21 to get the following. From here, the information in the brackets can be simplified to be 1,200, and 0.21 times 1,200 is equal to 252. So our answer is E.